To the first one. I already started that though. For the second question, as soon as they say what's the equation of a line, what I'm thinking is y equals mx plus b. And in this particular case, it's a line that's parallel. What do you know about the slopes of parallel lines? Same slope. Good. So it has to be this same slope, 3. And then it says the same y-intercept as this guy, which is 2. So it's y equals 3x plus 2. And generally, we did a nice job with that. This one, what's the slope of the y-intercept? And the problem is it doesn't say y equals. It says 3y equals. So I'm going to divide everything by 3. The slope is always the number in front of the x. It's 1/3. Remember, no x, just 1/3. And then 6 divided by 3 is 2. So the y-intercept is 2.
Oh, I thought you'd subtract everything back.
No, only if it said 3 plus y. Now, as far as graphing it goes, I begin at the y-intercept. That's why we call it b. So I begin at 2. Up 1 over 3, up 1 over 3. Jamie, be very careful. You kind of went up 2 over 3 to start, rather than up 1 over 3, okay? So that's what your quiz looks like. Tomorrow will be the last day in the series of the quizzes, and by then, whatever you get, you get. Hopefully, we continue to move up a little bit in terms of what it is that we're doing. Now, all about graphs and functions, and today we slide into studying one of the most famous topics in the history of mathematics, something that most kids tend to find very doable, okay? Well, algebra is a bigger topic. This is one topic within it. Okay, so, here we go. So, what we're looking for here is, in the do it, I believe this says negative 4/3, x minus 5 if the input's 12. So we have to do negative 4/3 times 12, y equals minus 5. And the easiest way to do this is to do the division first. It's always easiest to divide when numbers are small. So 3 goes into 12 how many times? 4. And then negative 4 times 4 is negative 16. And another negative 5 is negative 21. Okay? As far as which of these two graphs is a function, the second graph. First one fails the vertical line test. Third one, which of these is a function? B. First one's not because of the 2 3's. Next one, find the value of n in the similar triangles below. And now I have to copy the diagram from your page. 3 and 8. 3, 8. And then, let's say 9 and n. 9, n. As soon as you see this diagram, what do you start thinking to yourself?
Little is big.
That's it, guys, sing it. That was,
Beautiful.
yeah, a whole lot better than I can do. Hello. Jamie, early release. Frankly, I'm getting so close to just sending you through a phone. It's like you look for me to not pay attention to you so that you can do what you want to do. And I don't think at any point in time do you say to yourself, the most important thing that goes on in the room is learning, let me help with that. When you think like that, I got to do what I got to do. I don't want to do it, but you're forcing my hand. Now, stop doing that. Pay attention. All right, so the next thing that we're going to do is, yes, little is to big is little is to big. So the side of the little triangle 3 is to the side of the big triangle 9. They pair up, they correspond. Good word there, that word correspond. Now, this 8, is that the little triangle or is that the big triangle? Little. So that means the 8 goes in the top, and the n is from the big one. I cross multiply. 3 times n is 3n. 9 times 8 is 72. Dividing by 3, n is 24.
Wait, 24?
24 it is. Okay? Any questions?
I got 4.
72 divided by 3 is 24. Alex.
I'm supposed to
Okay, now we get to the fifth question, also about similar triangles. Two triangles are similar. The sides of the first triangle are 5, 9, and 11. The longest side of the second triangle is 22. So that means the 22 matches up with the 11. Now, yesterday, we talked about the ratio of similitude. Frankie, you did that really well. How do you do that again? Do you remember how you did it? Because you did it really well.
It's called the ratio.
Okay.
You just say it.
He just sounded very proper, like a college professor. Now, in this ratio of similitude, the scale factor, if this guy's 11 and this guy's 22, how many times is it getting bigger?
2.
2 times bigger. Good. So if I look up this perimeter, I'm going to get 20, and 5 makes 25. So what will the new perimeter be?
25.
No, the regular one's 25.
Oh.
Now, everything in the new triangle, if 11 goes to 22, how many times bigger is it getting?
Oh, 50.
Twice, so 25 times 2 would be 50. Another way to do it is to say little is to big, 11 is to 22, as the little one, 25, is to the big one, n. And if you cross multiply, you will come up with n equals 50. Okay, any questions on those? Now, the first 3 you should be good at. The last 2 you should either be good at or progressing toward being good. When these do-its are up on the board, what we're trying to get you to do is to have a sense of what's expected from you. They're not put up on the board to waste 4 minutes or 5 minutes or 8 minutes of class time. They're put up on the board to say to you, hey, you really want to know how to do this. And if you can do it, you're in good shape. You know what you're supposed to know. If for any reason you cannot do it, then we need to get to work on it. Now, today is Wednesday, so there is extra help tomorrow morning, okay? And you can come in for that. And then on Thursday morning extra help, there is none on Friday, and then you gotta wait all the way till Monday. So it's kinda like if you don't do it tomorrow morning, you stand a chance of falling further and further behind. And obviously, we don't want that to happen. All right. Today's lesson. Turn to the next page, everybody. Now, the first thing, yeah, it's a big fancy Greek word.
Hypotenuse?
Pythagorean.
Hypotenuse?
You know, it's funny when civilization was first, or Western civilization was first really being structured. Randy, let's turn, face forward, right? Your feet don't go on Davis's chair. One of the first civilizations was the Greeks, right? Now, the Greeks had their own priority system. For example, one of the things we get from the Greeks that's a really good thing is democracy, right?
Democracy.
Yep, and the Olympics.
And the
The Olympics and democracy came from Greece.
Yay.
And the Greeks, might have been your kind of people, they like to party. They very much like to party. They like to drink wine, like to drink a lot of wine. They like to go out on dates. And they like to do math.
No.
Yup.
Oh my God.
Those were the 3 things that the Greeks did in their spare time. Now, one of the most famous cults back then, and there were a lot of them, because they were a polytheistic society. Do you remember what polytheism is?
No.
I'll
I
let
feel like I do.
believe in
How could you not know what
Oh,
polytheism
you
is?
believe in the law of God?
That's right, multi
What?
God. Very good. And they would have like Zeus and Achilles, and they would have Apollo, yeah.
Yeah, that.
Now, I get confused as to which ones were Greek and which ones were Roman, because they were kind
Yeah.
of the same, you know?
Is it a different name?
Apollo was the nurturer.
Right, yeah, so, and it was Athena, right? They named
Athena,
Athens after
that's-
Athena.
Yep, she's
Right.
cute.
So, So they would have these cults that worship these particular gods. And one such cult was called the Pythagoreans. And their leader was a guy named Pythagoras. And Pythagoras, he was kind of a wild child, and what he would do is he would say, all right, everybody, on Friday night, we're gonna come to my place, and we're gonna bring the wine, bring your own wine. And then he would say, bring a date. And then he would say, we're gonna do math.
Okay.
We're gonna do math, and that's what he would do. Now Pythagoras, he came up with a whole lot of different things that were mathematical in nature, and what they would do is they would actually sit there and try to prove it. Nowadays, people argue, and they get in these arguments, which are really kind of difficult to win or lose. Like some people here might argue that Trump is a great president, he's doing a great job. And some people might argue that he's an awful president, he's doing an awful job. But the truth of the matter is that you can't really tell yet. And it's very difficult to say if what he's doing is a great thing or a bad thing. But what I can tell you is, mathematically, if you get into an argument, you definitely mathematically, if you get into an argument, you absolutely, positively can prove whether or not you're going to be right or whether or not you're going to be wrong. I'll show you what I mean. Pythagoras came out with this idea where he said that leg squared plus leg squared equals hypotenuse. Now, I think you learned the Pythagorean theorem last year. They worded it slightly differently. What they said was a squared plus b squared
I know that.
equals c squared.
Oh,
Now,
yeah.
that's the Pythagorean theorem, and I don't really like to say it that way, because if you do it that way, c has to be the hypotenuse. So if they ever put the c here or here, everybody gets it wrong. So I don't like to do it that way because of the possibility. I like to say leg squared plus leg squared is hypotenuse squared. Now, in a right triangle, this is the only time this is ever true, you have to first identify the right angle. The right angle is a 90-degree angle. There's 90-degree angles all over this room. The Eno board has 4 of them. Every cabinet has them. Every doorway has them. The tiles have them. The paper has them. Everything has right angles in it. Well, not everything, but almost everything in this room has right angles galore because we use it to make sure things are straight. Now, if you draw the right angle in your triangle, and draw a line straight across, which I'd like you to all do right now, and then the line straight across goes to the hypotenuse. And just label that hypotenuse. And the other two sides are always what we call legs. Now, the first thing I want to do is I want to be like in Pythagoras' day. Pythagoras says leg squared plus leg squared is hypotenuse squared. He actually said something slightly different, but close enough that we can work with this, okay? If I draw a square, because we just said before, leg what? Leg squared. So I'm going to draw a square there, and I'm going to divide it into 3. And since it's a square, all sides are the same. So how many little squares are inside the one big square? 9. Good. Now this guy's 4. And since it's a square, everything's the same size. How many little squares are inside the big square? 16. Now, this guy has a length of 5. So I'm going to divide this into 5. And since it's a square, everything has to be the same size. So how many little squares are inside that big square? 25. Now, isn't it true that 9, the first leg squared, plus 16, the other leg squared, is equal to the 25 squares on the hypotenuse? Right, isn't that true?
Wow.
What is 9 plus 16?
25.
25. So 25 is equal to 25. Now, that doesn't absolutely prove it. It kind of only proves it in that one case. But the truth is that there are ways to prove it for more cases. And that's the kind of thing that the Pythagoreans would get together and they would say, well, how do we prove this? How do we know it's always going to work? And there are certain sets of whole numbers for which this is true. For example, 3, 4, 5. And then using our scale factors, we could multiply that by 2 and get 6, 8, 10. We could multiply it by 10 and get 30, 40, 50, or 3 and get 9, 12, 15. They all work with Pythagorean theorems, but there are others. There is 3, 4, 5, 5, 12, 13, 8, 15, 17, 7, 24, 25, and multiples of all of those. And there are a lot of others that I don't even realize off the top of my head. But the point is to say to you guys that we can prove that it's true. And I find that really, really refreshing. Because sometimes, quite honestly, arguments about our government give me a headache. Now, I tend to be a center-right kind of guy, and I put on radio that's center-right, and I get a headache because they argue. And I definitely don't want to hear the left side of things too much because it's just Looney Tunes. So I get a headache right away dealing with them. So it can just give me a headache because nobody ever says to the other side, you know, you got a good point. Or nobody ever says to the other side, you're right. Very rarely. I could talk to Ms. Lau about it, and we'll say you're right, or Mr. Cipriano. But most of the time, if you ever notice, when people argue politics, you don't get anywhere. But in mathematics, and this is one of the great things I love about mathematics, is at the end of the day, I can prove it to you. Just like I, for the most part, did with this particular right triangle with the Pythagorean theorem. So from this point forward, we know that this is true. And we just want to be able to answer questions based on this Pythagorean theorem. So let me show you how we do it. And it's really not hard at all. So let's take a look at this first one. In every one of these diagrams, we always want to draw a right triangle, draw an arrow, and what side does the arrow always point to? The hypotenuse. So I like to label it HYP, which is short for hypotenuse. And then, underneath it, I like to write leg squared plus leg squared equals hypotenuse squared. Now, if this guy's the hypotenuse, what are the two sides over here and here? Those are the legs. So I'm going to put a 6 in place of one of the legs, and what am I going to put in place of the other leg? 8. And then I'm just going to use an h squared. What do you think h stands for? Hypotenuse. Very good. Okay. What is 6 squared? It means 6 times 6, right? 36. Good. Now, what is 8 squared? 64. Very good. 8 times 8 is 64. Is h squared. Is this the same side or an opposite side situation? Same side. So I do the same operation. What's 36 plus 64? 100.
100.
So I get 100 is equal to h squared. And now I think you begin to understand why in the last chapter for the last test I started to talk about square roots.
What happens?
Because to find h I have to square root both sides. In this case, I need to know the number that times itself is 100. No, 10. 10 times 10 is 100. 25 times 25 is 625. So h is 10. And that's the correct answer. Okay, you guys try the middle one. Let's see how you do. What?
Does that mean I have to draw 12 lines if I want to?
No, well, if you wanted to prove it all out, yeah, that's why I did 3, 4, 5. That's the smallest one, it's easiest. But we should just use the formula. The Pythagorean theorem. Remember, the Pythagorean theorem only works in a right triangle. Does not work in an acute triangle, only a right triangle. No acute, no obtuse, no Italian, no German, just a right triangle, which is also known as
Right triangle.
a Lindquist triangle. Yes, I'm always right.
Oh.
That
That was good.
Let it pass
Where do kids come from?
Wait, so we multiply the hypotenuse by 6.
First, draw the right angle, label the hypotenuse, leg squared plus leg squared, hypotenuse squared. That's it, keep working. One said, shh, I heard you when I was in there, very good. Good work. Okay, ready? You know, when I was in high school, I had this great math teacher named Mr. Poten. Poten, P-O-T-E-N. And he used to tell me all the time, don't bother memorizing formulas. And that was in 11th grade, and that was some serious formulas. And he would say, just write it every time you need it. And if you do that, you'll always remember it. So, even now, every time I need it, I write it. Leg squared plus leg squared is hypotenuse squared. No flashcards, no studying it over and over and over, just use it every time. Every time you write it, every time you need it, write it. Now, here's my right angle. Here's my hypotenuse. The legs are 5 and 12. So 5 squared plus 12 squared equals 8 squared. What is 5 squared? 25, good. What's 12 squared?
Oh, I wrote.
Equals 8 squared. If you add them up, you get 169.
Yep.
Now, I don't know if you know what the square root of 169 is.
13?
13, very good.
Yeah.
Wait, you divide by what?
You don't divide by anything. You ask yourself what number times itself is 169, and the answer is 13.
So 13 times 13 is 69?
Mm-hmm.
So you can't do anything else that's simpler than that?
That's the way to do it. That's what square root means. Okay,
You just gotta multiply.
now, let's see you try. Don't solve this next one. Just set it up. Okay, set up the next one. Don't solve it.
How?
You gotta make sense. It's 20
That one's
Okay. We have about 30 seconds, guys.
Can we answer that? The third one?
Set it up, I said. Don't pack up. Okay, now,
I think you said it.
Set it up wrong.
No, yeah.
And it's supposed to be where the 15 is.
either way, doesn't matter. They're both legs, right? Do not pack up. I'll keep you after the bell. Start paying attention. Look. That's the hypotenuse. These are the legs. So n squared plus 15 squared equals 17 squared. What's weird about this one?
The end is
The
the
other
wrong
leg.
place.
The end's in the right place. It's in a different place.
Oh.
This is not a same side situation. This is opposite side.
What the?
What?
15 squared is 225.
Oh.
17 squared is 289. The key is you gotta subtract. We have 2 more days of the Pythagorean theorem left. Hasta la vista, vaya con Dios, toodaloo, ta-ta, arrivederci. Smile a lot. Ciao. Ladies and gentlemen, see you later. Adios, amigos y amigas. Cheerio. Garushus. Gadafis.
It's called,